In this video, we're going to look at the solutions to AQA's Level 2 Certificate Further Mathematics, Paper 1, and this is from June 2023, or Summer 2023. This is a non-calculator paper, and the time allowed is 1 hour and 45 minutes. Okay, first question says, the function f is given by f of x is equal to 2x plus 1. Work out x when f of x is equal to minus 5. So to do this, just put minus 5 is equal to 2x plus 1, and then it's just a solving equation. So minus 5, then minus 1 is equal to 2x, that's minus 6 is equal to 2x. That means minus 6 divided by 2 is equal to x, or x is equal to minus 3. Next question said, the function is given by g of x is equal to x squared. Work out f g of 3. I'll show you two ways of doing this one. First way is using a composite functions way of doing it. So f g of x, first of all, what that means is you do f to your g of x. Now that means you're doing f of x squared. So you're putting x squared through the f function. Now the f function, what it did, it multiplied something by 2 and then it added 1. So we're going to do that to our x squared. So you're going to multiply it by 2 and then you're going to add 1. Now once you've done that, then you can say what f g of 3 would be. So just replace or substitute in 3. You'll have 2 times 3 squared plus 1. 3 squared would be 9 times 2 would be 18 plus 1 would be 19. Okay, is there another way of doing this one? Okay, well what we could do, a different way of doing this one, we could do, just do g of 3 first of all. So do g of 3, that means 3 squared, which gives you 9. And then do f of 9 and see what that gives you. And f, remember, was 2 times the x, so 2 times 9 in this case, plus 1. And again, that gives you 19. Next question is a factorizing question. It says factorize fully. So look at what's common. You can pull a 3 outside of this and pull a 3 out of the 21. So 3 comes out first. You've also got an x you could pull out and a y. So 3xy comes out. And then you're thinking 3 times what gives me 6x squared y. And 3 times what gives me the 21xy. So let's break this up. First of all, 3 times 2 would give you the 6. X times x would give you x squared. You've already got the y, so you don't need anything else. Next one then, 3 times 7 would give you 21. And x times 1 gives you x, y times 1 gives you the y. That's us done. Okay, next one says, circle a transformation matrix that represents a reflection in the line y equals minus x. Okay, right. I'm going to look at my unit square for this. I've forgotten these. I'm going to look at my unit square. Do this from where this comes from the proof. Right. So that's my unit square. This is my point 1, 0, and this is my point 0, 1. I need to see where these 2 points go if I reflect in the line y equals minus x. So if I draw it on, there's my, oops, that's wrong, that's my line y equals x, apologies. That's my line y equals x I've just drawn. Made a real mess of that one. It's y equals minus x, so it's down this way. There's y equals minus x, and you should be able to see that this point up here, first of all, it reflects down to here. So that's going to be minus 1, 0. And this point here will reflect down to here. So it reflects to 0, minus 1. So to find where a matrix goes, what the transformation matrix is, you need to see where 1, 0 goes to and where 0, 1 goes to. And then you push those two columns together. So 1, 0 became 0, minus 1. 0, 1 became minus 1, 0. So my answer is push those together, 0, minus 1, and minus 1, 0. So it is the first one. Okay. Next one says, show that the product of these two matrices is k times I. Just remember, what is I? I is the identity matrix. So it's going to be some multiple of that matrix. Okay, so let's look at the left-hand side. If you multiply that out, okay, how you multiply matrices, talk about matrices is very important. This element here, it's not the top left. It is the top left, but the way we're going to think of it is first row times the first column. So you multiply your first row by your first column. So if you do that, what you will get is 2 times minus 3, which is minus 6, and 4 times 1 is 4. Minus 6 plus 4 is minus 2. Then this next element is first row, second column. So you're doing 2 times minus 4, which is minus 8. 4 times 2, which is 8. Minus 8 plus 8 is 0. That's good. That's what we're sort of hoping to be getting. And then the next one, whoops, apologies. The next one then, this one is second row, first column, second row, first column. So it is minus 1 times minus 3, which is positive 3, minus 3 times 1, which is minus 3, positive 3 minus 3 is 0. So that one is just 0. That's what we're hoping to get. And I'm hoping to get minus 2 in this last one here. So the last one in here, how I get it is second row, second column. So that's minus 1 times minus 4, which is plus 4. And then minus 3 times 2 is minus 6. 4 minus 6 is minus 2. And that is minus 2 as we want. So we have shown it is equal to that. I don't know, did they want k? K would be equal to minus 2. Just put that in just in case they want it. I don't think they do. I think that's all they have to do. Okay. Lovely. Straight lines question. S is equal to 7, 5, and T is equal to 5 minus 4. And they are points on a straight line. Work out the gradient. Okay, your gradient, now my way of doing the gradient is the y difference over the x difference. You may have learned that your points, if your points are x1, y1, and x2, y2, then your gradient will be equal to y1 minus y2 over x1 minus x2. You may also want to draw a diagram. I'm hoping you're better than having to draw a diagram here, to be quite honest. So we're going to just do it my way. So the y difference. Now the big thing is I'm going to start with this coordinate here. So I'm starting with this one. So 2 minus 4. So I've started with that yellow one. So I start with it on the bottom for the x's, 7 minus 5. Tidy that up. 2 minus 4 is 2 plus 4, which is 6. 7 minus 5 is 2. So my gradient works out to be 3. Part B says work out the distance between S and T. Right, I need to write down what my S is here. Otherwise I'll be scooting back. 7, 2 and 5 minus 4. Okay, work out the distance between these. Right, your distance, or your length, as I would have called it, really, length between 2 points on a line, is equal to the square root of the y difference squared plus the x difference squared. And again, you may have learned this off as y1 minus y2. I don't know why I wrote it that way. Normally I write x difference squared plus y difference squared. Doesn't make a button difference. Okay, just by the way, the gradient, on the gradient, it matters which way you do it. It doesn't matter so much in this because of the squaring, so you're sort of sorting this out anyway, but let's do it right. So here, y difference squared then, so what was it, 2 minus 4, sort of done this working out already, and then 7 minus 5, so that's going to be 6 squared plus 2 squared. And if you do that, what is 6 squared? 6 squared is 36. 2 squared is 4. 36 plus 4 is 40. And then we could rewrite that as root 4 times root 10, which is the same as 2 root 10. Is that what we're looking for? Yes. Right, give our answer in the form A root B, where A and B are both integers greater than 1. Lovely. There we are. Very nice. Okay, this is a wee proof question. xn and yn are the nth terms of two sequences. So your first sequence is this one, n minus 1 upon n plus 1. Your second sequence is n plus 1, n plus 2 upon n plus 2. Prove that every term of the sequence yn minus xn is a multiple of 3. Right, just got to investigate. I have no idea. Let's investigate and find out. So yn minus xn would be n plus 1 upon n plus 2 minus n minus 1, n plus 1. Okay, I'm going to do this second one here. This second one, I'll do it as in one bracket. This, you should be aware, is a difference of two squares, so that's what it becomes. Next one, a wee bit trickier to do. So we do it out. You have n times n is n squared, n times 2 is 2n, plus another n, that's going to be 3n, plus 3. And then we'll tidy up. Let's just get rid of those brackets. I would take this step. Very good mathematicians that I've taught over the years, that's a mistake. The mistakes they would make would be just trying to skip from here to here. So I would definitely do that step. Now n squared minus n squared, they disappear. Then you're going to have 2n plus 3. I've got 2n. It should be 3n plus 3. It should be 3n plus 3, otherwise it wouldn't have worked. 3n plus 3 is what it's going to be. 3n plus 4. If I made a mistake here, I have made a mistake. You see my mistake? My mistake was up here. I can't multiply 1 by 2. That's what my mistake is. So 1 times a 2 is just 2. And then when you tidy it up, then that becomes 3n plus 3. Okay, so very nice. I was able to correct my mistake there. Well, two reasons. I'd set my work out well, and also they told us a question. They told us it was a multiple of 3. I wasn't going to get a multiple of 3. We could then write that as 3 upon n plus 1. Just say hence a multiple of 3. Okay, so just take care. Talking so much about how people make mistakes. I made some myself. Right, next one. Right, the circle of a curve is y is equal to x to the power 6 plus 4x squared minus 7. Work out the equation of the tangent. Okay, right. If you see words such as tangent, normal, perpendicular, parallel to, maximum, minimum, turning point, any of these words, you should be thinking, right, is this a differentiation question? And it is going to be. So you've got an equation of the curve. I have no idea what this curve looks like. But what dy by dx does is we've got loads of different names. The most important one is it is the gradient function. So if you've got some weird and wonderful curve, what the gradient function dy by dx does, it allows you to find the gradient of that curve at any point. It's ever changing, the gradient of this curve, as you can clearly see here. And the dy by dx, what it does, it creates a function which if you plug in the x value, it allows you to find the gradient of that curve at any point. Lovely, lovely bit of mathematics too. Right, so here, let's just write down, set your work out nicely. Write down your y. Y is equal to x to the power 6 plus 4x squared minus 7. And we're going to differentiate. And if you differentiate, you will get 6x to the 5 plus 8x. That's it. So when you differentiate, if you've got y is equal to a to the power of x, x to the power of n, your dy by dx is equal to a n x to the power of n minus 1. So what you do is you multiply by the power and reduce your power by 1. Okay, so this is your gradient function. It allows you to find the gradient at any point. So at the point 1 minus 2, so just say when x equals 1, dy by dx will be 6 times 1 to the power of 5 plus 8 times 1, which is going to be 14. So your tangent is y is equal to 14x plus c. Okay, and then we need to find the c. We've got to sub in the point with the point 1, 2. So just say sub in, run out of space here. 1 minus 2, you really shouldn't run out of space. There's plenty of room there if you were doing this on a regular bit of paper. So minus 2 is equal to 14 times 1 plus c. So that's minus 2 minus 14 is equal to c. So your c equals minus 16. And remember to give your answer as 14x minus 16. Hopefully I've made no mistakes there. It's a lovely question. Okay, right, we've got a geometry here. It says the diagram below shows a cone in a prism. All measurements are in centimeters. The cone has a base radius of r and a perpendicular height of x. The prism has a triangular cross section with a base y and a perpendicular height y, and the length is x. The volume of the cone is 4 times the volume of the prism. Okay, no idea. Express r in terms of y. Right, let's just find our volume of our cone. It is a third times my base. So its base area is going to be pi r squared. Whoops. Pi r squared times my perpendicular height, which is x. The volume of the triangular prism, we'll just say prism here, is, it's a half times the base times the height. So it's a half times y times the length, which is x. So it is x y squared, xy squared all over 2. Okay, now these two things are linked because it tells us the volume of the cone is 4 times the volume of the prism. So let's put that in words. People find this very difficult to do. So just say, write that, say volume cone, not in words, but just this form without the pi and the r and the x and so on. So volume of the cone is equal to 4 times the volume of the prism. Okay, and then we'll change it into their form. So that means 1 over 3 pi r squared x is equal to 4 times x y squared over 2. And then tidy this one on the right hand side up. 4 times that half basically is just going to be 2 x y squared. Still got a third pi r squared x. Let's just do a wee bit of cancelling down here. Going to get rid of the x first of all, so I'll have pi r squared is equal to 2y squared. What are we to do in this question? Express r in terms of y. So we've got to find what my r is. Let's finish this off over here. Going to multiply across by the 3. So I'll have pi r squared is equal to 6y squared. Then I'll have r squared is equal to 6y squared over pi. And then my r is equal to the square root of 6y squared over pi. Notice I haven't bothered with a negative square root because it's a dimension. For my r, it's going to be a positive value. Okay, circle has a center, the origin, and radius 5. A straight line has equation 2y is equal to x plus 5. Work out the coordinates of 2 points where the circle and the straight line intersect. Do not use trial and improvement. Okay, first of all, the circle has the equation, a circle centered the origin has equation x squared plus y squared equals r squared. So 5 squared, just write it this way first, that means x squared plus y squared is equal to 25. We'll call that equation 1. And my line, I'm going to rearrange my line a wee bit. No, I'll not rearrange my line at all. I will rearrange my line a wee bit, but I was going to say to make y the subject and to make x the subject would make it easier. So my line was 2y equals x plus 5, which means you could rearrange that and say then x equals 2y minus 5. Call that equation 2. And we're going to sub equation 2 into equation 1. So my equation 1, everywhere I see my x, I'm going to replace it with 2y minus 5. So it's actually going to be a quadratic in terms of y. Right, take this step please. I've already demonstrated how easily it is to make a mistake multiplying out brackets earlier on, so I'll take a wee bit more care here. 2y times 2y is 4y squared. 2y times minus 5 is minus 10y. You have another minus 10y, so that's minus 20y. And minus 5 times minus 5 would be plus 25. Plus y squared equals 25. Bring everything over to one side and tidy up. I will have 5y squared minus 20y. Oh, 25 minus 25 is 0. Happy days. Look, nice easy quadratic. Pull the y outside a bracket. You'll have 5y minus, or I could have pulled out a 5y even. That would have been better. Pull a 5y outside a bracket. I'll have 1y minus 4 equals 0. You're in a lovely stage of mathematics here. You've got a times b equals 0. That means either a equals 0 or b equals 0. So here, that means 5y equals 0, which means y equals 0, or y minus 4 equals 0, which means y equals 4. You've done all that hard work, and they've been nice to hear. They've sort of led you through it, showing you need the coordinates. You've got the y values. You need to find the corresponding x values. So just say, we'll zoom in a wee second, when y equals 0, sorry, let me just write down the equation of my line, x equals 2y minus 5, and we'll zoom in, so y equals 0, and then I've got when y equals 4. Okay, so there were my two y values. Find the corresponding x values. So when y equals 0, x equals 2 times 0 minus 5, x equals minus 5. So that gives you the point minus 5, 0. And the other one, when y equals 4, x equals 2 times 4 minus 5. 2 times 4 is 8, minus 5 is 3, so that gives you the point 3, 4. Okay, now let's just look. We actually can tell by looking at these points that we're going to be right. Let's look at this equation here. My circle, was x squared plus y squared equals 5 squared. So it was a circle. If I had it, I'd go right up here, it would make it much easier to see. I had a circle, centrally origin radius 5. And sure enough, what were my points? One was 3, 4. So you imagine there's my 3, 4. 3 horizontally, 4, and you can see that makes a 3, 4, 5 triangle. And this one, minus 5, 0. Minus 5, 0 would be here. So you can see that radius is also going to be 5. So it makes perfect sense for those 2 points to be on your line. And you imagine you'd have your straight line must have gone through those 2 points. Okay. Right, lovely. Oh, even nicer. Gets better and better this exam. Rearrange. W is equal to y squared plus 5 over y squared minus 2 to make y the subject. Okay, in general mathematics, if the thing you want is on the bottom line, it causes a problem. So try and get it off the bottom line as soon as you can, as long as you're not breaking any rules. So it was dividing, that whole thing, y squared minus 2 was dividing, so the whole thing multiplies. Then multiply out, you'll have w y squared minus 2w is equal to y squared plus 5. Let's bring all the y squareds, I should say, across to one side. Everything else can clear off the other side. Factorize out your y squared. You're left with w minus 1 is equal to 2w plus 5. And then we'll divide across. You'll have 2w plus 5 divided by w minus 1. And then your last line, your y is going to be equal to plus or minus the square root of 2w plus 5 all over w minus 1. So there you have it. Okay, so that whole thing is being square rooted. Extend your square root there so it's obvious. And it's plus or minus, we have no idea if it's positive or negative. I have to put the plus or minus in. Lovely. Next one, rationalize the denominator and simplify fully. 1 plus root 5 all over 3 minus root 5. To do this, what you do is you multiply the top and bottom by, well, I suppose we could call it the conjugate of this thing. So you just change the sign of the second thing. Okay, and that will sort it out. What happens, it gets rid of the surd on the bottom line, the square root on the bottom line. Just so we know, that's one people are quite good at doing. Had the question said this, would say it said 7 plus root 6 over root 2 minus, we'll say 3 root 2, minus 1. What you would multiply is top and bottom, I'll change that there, plus 1, top and bottom by 3 root 2 minus 1 and 3 root 2 minus 1. So it's a sign of the second thing you change and you multiply top and bottom by it. Okay, so let's just do it. Again, I'm going to run out of space here. Right. Right, you've got 1 times the 3, it's just 3. 1 times the root 5, I'm just going to show all the steps here. That's going to be root 5. And then root 5 times the 3 is 3 root 5. 3 root 5. Root 5 times root 5. Root a times root a is just a. So root 5 times root 5 is just 5. Now, the bottom line is the difference of two squares, okay? And people do not like this, so we'll just do it out. We know, just accept the fact that people are not going to see the different two squares. We're just going to do it out this way. 3 times 3 is 9. 3 times the 5, root 5, sorry, is 3 root 5. Minus root 5 times 3 is minus 3 root 5. And minus root 5 times minus root 5 is minus 5. Now you can see in the bottom line, these two terms, the surd terms, cancel each other out. Top line is 8 plus 4 root 5. Bottom line is 9 minus 5, which is 4. And I'll set this out really well here if I do say so myself. This is a nicer way of doing it than just dividing everything through by 4. If you factorize out first, and then you can see 4 divides into itself once, 4 divides into that once, and that just leaves you with 2 plus root 5. Lovely. Next question says, work out the positive value of x for which d2y by dx squared is 55. Okay, if you were looking at my notes, I have got something in my notes which says this. I've go from y to dy by dx by differentiating, and I go to d2y by dx squared by differentiating. So we're going this way. I differentiate with respect to x. Going the other way, you would do the opposite. You would integrate with respect to x. But it's d2y by dx squared, which means we've got to differentiate. And you've got to differentiate this twice. So we've got y is equal to 1 over 12 x to the 4 plus 3x squared plus 4. Differentiate this thing first of all. So we differentiate by multiplying by the power. 4 times a 12th is 4 over 12, which is 1 over 3. And that's x to the 3 plus 6x. That's it. Differentiate again. 3 times a third is just 1. That's going to be x squared. 6x differentiate just gives you 6. There we go. Okay, work out the positive value for which d2y by dx squared is equal to 55. Okay, right. So just say put 55 equal to x squared plus 6. That means 55 minus 6 is equal to x squared. So what's 55 minus 6? It is 9. Oh, very nice. 49 is equal to x squared. So x is equal to plus or minus the square root of 49, which means x is equal to plus or minus 7. It said the positive value. So your answer, x is equal to plus 7. Very nice. Nice question. I really like these exams. These are very good. Turn over for the next question. Okie dokie. Where are we? Okay, right. Right. Write down the value of x for which sine x is equal to minus 1. Now, I use what's called the cast diagram to do this. So I would know, there's my cast diagram. I'm not too sure how we're meant to do this. I think maybe you're meant to know the graphs. So write down the value of x for this, but I would know that sine equals 1 at 90 degrees. So 90 degrees is here. In the opposite place then, it would be equal to minus 1. So the opposite place is here. So my answer is x equals 270 degrees. Now, you maybe haven't done it that way, maybe don't like that. So the other way you do it is if you just know your diagram. And your sine graph starts like this. That being 360, that's 180. So that's going to be, that's 1 as well, and minus 1. So that's 90, and that's 270. So you can see it's equal to 270. Sorry, it's equal to minus 1 when it's equal to 270. So whatever way you prefer. It's definitely like the Google cast diagram for that. All right, work out the values for y, for which, for 0 to 360 when tan root 3 tan y is equal to 1, right? Let's rearrange that first. So that means tan y is equal to 1 over root 3. Okay, right, how do we get our 1 over root 3 1? Right, we need to find our basic angle first of all. This is a non-calculator exam. So let me just write these. I'll just do sine 30 and sine 60, just in case we forget these. We should remember that sine of 30 is equal to half. Sine of 60 is root 3 over 2. Cos of 30 then is, they're the opposite way around, so it's root 3 over 2. And cos of 60 is equal to a half. Your tan, how you get your tan of 30 will be equal to this one divided by this one, which would be 1 over root 3, and tan of 60 is equal to root 3 over 2 divided by half, which is just root 3. So you can see your basic angle, your first angle is, this one is going to be, so therefore y is equal to 30 degrees. Okay, that's one of your angles. Now, again, I'm going to do this two ways. I'm going to use a cast diagram and use the graphs just. I'm not too sure which way you would do it. For the cast diagram, and I'm imagining this is not the way you do it. For the cast diagram, there's your C, A, S, and T. There's 0, 90, 180, 270, and 360. So 30 degrees is in here. And that's where A stands for them all being positive. So sine, cos, and tan are positive between 0 and 90 degrees. Or in here, tan is also positive, so the T stands for tan being positive. So 30 degrees is one of my answers, and also round to here, that's going to be 30 beyond 180. So my answers are y is equal to 30 degrees, or y is equal to 30 beyond 180, what is wrong, I can't count, 210 degrees. Okay, so there's how you use your cast diagram. I think that's a really easy way of doing it. Right, the other way of doing it then is using your trig graphs. So okay, so by your trig graphs, but you can see by symmetry. If I went 1 over root to 1 over root 3, it's just a sketch here, by the way. So, and this was 30 degrees beyond this point. Then by symmetry, 30 degrees beyond this point would also be that. So you can see that's another way of doing it. So you can see you can get the same answers, 30 and 210. Okay, right, algebraic fractions, lovely. Write this as a single fraction. Right, we're going to take a common denominator of 3x. So the first one needs to get multiplied by 3. Next one's there. The next one, that's really 1 over 1. So the 1 on the bottom line gets multiplied by 3. The 1 on the top line gets multiplied by 3 as well. Let's just tidy up. That's going to be 6x minus 9 minus 1 plus 3x. All over 3x, which is going to be 9x minus 10 all over 3x. And they've probably done this, so people will make the mistake of cancelling these out. You cannot do that, absolutely not, because the x on the top is not multiplying everything on the bottom. As good as we can go. Let me just check that. 3 times the 2x minus 3, that's 6x minus 9, then minus 1, and then plus 3x, 6x plus 3x is 9x. Yes, that looks good. Okay. Right, quadratic inequalities here. First thing to do is bring everything to one side. 8 over x plus 3x, minus 10 is less than or equal to 0. Multiply through by x, you'll have 8 plus 3x squared minus 10x is less than or equal to 0. Let's just write that as 3x squared minus 10x plus 8 is less than or equal to 0. Okay, hopefully this factorizes, I do not know. My sum is minus 10. My product is 24. So let's go through 24, and both numbers need to be negative. Minus 1 times minus 24, minus 2 times minus 12, minus 3 times minus 8, and minus 4 times minus 6. Happy days, it factorizes. So what we've got then, I'll do this over here. I'm going to run out of space in this one for sure. We can rewrite this thing as 3x squared minus 4x minus 6x plus 8 is less than or equal to 0. So if we factorize the first two terms, you'll have x upon 3x minus 4, then minus 2 upon 3x minus 4 is less than or equal to 0, which means 3x minus 4 upon x minus 2 is less than or equal to 0. And then, where do we do? Okay, this one would be x equals 4 over 3. This one would be x equals 2. So that's where our U shape, our positive quadratic crosses at, that's 1 1/3. 1 1/3 and 2. And we want it to be less than 0. So we want it to be underneath. And it's underneath between here and here. So my answer, 1 1/3 is less than or equal to x is less than or equal to 2. Hopefully that is what we're looking for there. Nice question. Okay, right, next of all, solve this thing here. Okay, I have no idea. That looks pretty nasty. Let's go for it. Let's look at our left-hand side first. We're going to multiply it out. You've got x to the power of a half minus x to the power of 3 over 2. And that's times x to the power of a half minus x to the power of 3 over 2 is equal to x squared plus x. Right, I'll get a bit of working out to do here. X to the power of a half times x to the power of a half. Add the powers, you'll have a half plus a half, which is just 1, so it's just x. And x to the power of a half times minus x to the power of minus 3 over 2. Again, adding the powers, you'll have x to the 4 over 2, which is just x squared. Same idea here, you'll have another x squared, and then this one times this one, that's going to be x to the 6 over 2. What is 6 over 2? That's going to be plus x to the power of 3. And that equals x squared plus x. Tidy up the left-hand side, you will have, or you know what, bring it all to one side. You'll have x cubed minus 3x squared equals 0, because the x's cancel out, right? I don't think I've made any mistakes there. Looks sensible. That means take x squared outside a bracket. You'll have x minus 3 equals 0. And you're in a weird situation again where you've got a times b equals 0. So put a equal to 0, put your b equal to 0. So here, x squared is equal to 0, which means x is just equal to 0, or x minus 3 is equal to 0, which means x equals 3. Beautifully engineered question. That's very nice. Whoever made that question, tip of the hat to you. Well done. Right, next one says the expansions of 1 plus 12x to the power 4 and a plus 4x to the power 3 have the same coefficient of x. Work out the value of a. Okay, we're going to do this using what's called Pascal's triangle. Now, Pascal's triangle is the following. One more row to go. Okay, now we're going to expand these things partially. We're only going to look at the coefficient of x squared. So the coefficient of x squared in this thing would be 1 would be the coefficient of 1, 4 would be the coefficient of, sorry, I'm not quite right what I'm saying, 4 would be what you're multiplying everything out here by, so that would give you the 4 would be in front, 1 would be in front of the numerical term, 4 would be in front of the x term, but there's also going to be more to it than that because there's a 12 involved. 6 would be in front of the x squared term, and we'll have to look at this. Okay, so for that, the coefficient, sorry, I'll say the coefficient, we'll just say the x squared term would be equal to 6 times, and then you're going to have 1 squared times 12x squared. So that's going to be 6 times, and that's just going to be 12 squared plus 12 squared, 144 times x squared. Okay, now for the other one, what was it? A plus 4x cubed. The x squared term, we're looking at this row here, the 1, 3, 3, 1. So my numerical term is going to have a 1 multiplying it. The x term is going to have a 3 multiplying it. The x squared term is going to have a 3 multiplying it as well. So it's going to be 3 times, and that's going to be a to the power of 1. So just a, and then times 4x squared. So that works out to be 3a times 16x squared, or whatever that's going to be. That's going to be, you know what, I will leave it like that. I'll work with this. Okay, now I've had to go across the page. I've run out of space. Now these two things are equal. So sorry, it says that they have the same coefficient. So that means this thing here, this thing here, 6 times the 144 is equal, x squared equals 3a times 16. So I'm just going to write that down and zoom it in. So 6 times 144 is equal to 3a times 16. Now I haven't multiplied it out because I didn't think it would make it much easier for me. So we can, now what we can do is do a wee bit of cancel. 3 goes into itself once, 3 goes into that twice. And what else could we cancel? On both sides here, I'll just divide through. I'll divide through this by this 2 again. 2 goes into itself once, 2 goes into that. 2 goes into that 8 times, and we'll divide that by 2. So that goes down to 4. That goes down to what? That goes down to 72. And then divide by 2 again, that goes down to 36. Divide by 2 again, that goes down to 2. And divide by 2 again, that goes down to 18. Divide by 2 again, that goes down to 1. So you've got a is equal to 18. Let me just check on a calculator, have I done that correctly? I'll just do 6 times 144 and divide by 3 and divide by 16. I got 18, yes, so that is right. So there you how you can do that without a calculator by a lot of cancelling down. So wouldn't be an advantage really to multiply the 6 times a 144. That would make it more difficult. It probably made it more difficult for myself by multiplying out that 12 even. The 12 squared should have left it as 12 times 12. Anyway, I would have made it much easier. Right here, we'll do that very quickly here just to show you. Right, so what was it? What have I said? So if it had been 6 times 12 times 12 is equal to 3a times 16, you could make that much easier. That would go, and that would go down to 1. That would go to 2. And then 4 goes into 12 3 times, and that goes into that 4 times. 4 goes into 16 4 times, and then you can cancel down again by, well, you know what, I wouldn't even, I would just do, or would I? I would. 4 will go into itself once, 4 will go into that 3 times, and then you've just got on the right hand side, you've got 1 times a times 1, so just a. Left hand side, you've 2 times 3 times 3. 2 times 3 is 2 times 3 is 6 times 3 is 18, so a is equal to 18. So it's slightly easier doing it that way, but definitely don't multiply everything out. You've non-calculator, you've got a tricky enough question to do without a calculator. Right, the curve y is equal to ax cubed plus bx squared plus 7 has a stationary point at minus 2, 11. Right, I mentioned this earlier on. The words stationary point, turning point, maximum, minimum, tangent, normal, parallel to, perpendicular. You should always be thinking, right, is this something to do with dy by dx? So this is definitely a dy by dx question. So differentiate first of all. So differentiating this, you're going to get 3ax squared plus 2bx, okay, has a stationary point So at a stationary point, that means you put your 0 equal to 3a times minus 2 squared plus 2b times minus 2. So that 0 is equal to minus 2 squared would be 4 times 3 would be 12a. Minus 2 times 2 is going to be minus 4b. Call that equation 1. Okay. Sort of question really trips people up here. They think, well, how am I going to solve this? I've got one equation and two unknowns. But this point here is on your curve. So we have to sub that in as well. So just say sub minus 2, 1, 1 into the original curve. So you fire it in and you're going to get 11 is equal to a times minus 2 cubed plus b times minus 2 squared plus 7. So it's 11 is equal to minus 8a plus 4b plus 7, which means 4 is equal to minus 8a plus 4b. And you know what, leave it like that. Normally I would divide through, but if you notice, you've got minus 4b and plus 4b in these two equations, so leave them as they are. Just going to write my other one underneath it, my first one. All we want to do here is add. If you add those two things, you're going to get 4 is equal to 4a. A then equals 4 divided by 4a equals 1. And then put that back into equation 1. 0 is equal to 12 minus 4b. 4b equals 12. Your b works out to be 12 divided by 4. B equals 3. So you've got your a equals 1 and your b equals 3. And is that it done? It is indeed. Lovely question again. Right, simultaneous equations with 3 unknowns. Okay, let's write these out again. I've got 2x plus y equals 13 is my equation 1. Notice I've left the gap. Then x plus 3z, I've left the gap for my y this time, is equal to 2. That's equation 2. And then minus 2y plus z is equal to minus 7. Okay. Whatever way you want to do it, there's no easier way of doing it. You could get rid of the y's or the x's or the z's just as easily. So I'm going to get rid of the x's. So I'm just going to write that down, just say eliminate x. So I'm going to, keeps me right. So that means I'm going to multiply my equation 2 by 2, which gives me 2x, leave the gap, plus 6z. Sorry, 2x plus 6z is equal to 4. And then we'll write our original one underneath it, my equation 1. Then we're going to just subtract. So I'm just going to do 2 times equation 2 minus equation 1. That's just going to give me minus y plus 6z is equal to minus 9. That's my equation 4. We'll write our last equation, our equation 3 underneath it. So we're going to eliminate our something. I'm going to eliminate y's, I think, from these two equations. So I'm going to say eliminate y. So I'm going to multiply my equation 4 by 2. So I'll have minus 2y plus 12z is equal to minus 18. And then we're going to subtract. So we're going to do 3 minus 2 times equation 4. So z minus 12z is minus 11z. Minus 7 minus 18 is the same as minus 7 plus 18, or 18 minus 7, which is 11. That means z is equal to minus 1. Put it in a wee box. Sub that back into equation 3. I will get minus 2y minus 1 is equal to minus 7, which means minus 2y is equal to minus 6, which means y is equal to 3. And then we'll fire it back into equation 1. Can we fill that back in equation 1? We can indeed. Fire it back in equation 1. You'll have 2 times my x plus 3 is equal to 13, which means 2x is equal to 10, which means x is equal to 5. And there we have it. Done. Okay, next question, question 18. Lovely identity question. You have got 8x squared plus 20x plus n is equal to c upon x plus d squared plus 3. And we've got to work out the values of c, d, and n. So this is one where you're going to find your left-hand side and put it equal to the right-hand side and so on, and then equate the coefficients. So that means a number that's multiplying a thing. Write down RHS, that means right-hand side, and it's c times x plus d times x plus d plus 3. Oh, I don't think this is going to be nice at all. It's going to be tricky. So multiply it out. X times x is going to be x squared. X times d is dx plus another one, so that's 2dx. D times d is d squared plus 3. Multiply it again, you'll have cx squared plus 2cdx plus cd squared plus 3. Now, we're going to have to equate the coefficients. So 8, straight away we've got one. 8 equals the c, because they are x squared terms. So I'm getting this, I'll just say x squareds. 8 equals c, therefore c is equal to 8. My x terms then I can do. So if I look at my x terms, if 20x equals 2cd, so 20 equals 2cd. So that's the same as 20 is equal to 2 times 8 times d. D is not going to be very nice. So that's 16d. So 20 over 16 equals d. A wee bit of cancelling down here. Top and bottom divide by 4 to give you d is equal to 5 over 4, or 1.25. 1.25. Okay, just n to get. To get your n, you're going to have to look at your numerical term. So my numerical term is cd squared plus 3 equals n. So I'll just say numerical. Right, it's also the x to the 0 term. If you are happy with that, if you're not, don't worry. So it was n was equal to cd squared plus 3, n equals cd squared plus 3. So here we go. N then is equal to, what's my c? My c is 8 times my d squared, so that's going to be 5 over 4 squared plus 3. Okay, let's zoom in so we can actually do this. Right, not easy. I wonder if I made a mistake here. 25 over 16 plus 3. And then the 8 goes into the 16 twice, so you're left with 25 over 2 plus 3. What's 25 over 2 going to be? That's going to be 12.5 plus 3. N is equal to 15.5. It could be, I suppose. No reason why not. I've certainly got most of the marks for working out. If I've made a mistake, I've made a mistake. Who knows? But that looks all right. The rest of it, anyway. I can't see where I've made a mistake. I'm going to guess that is right. Okay. Oh dear. Right. Here we go. Circle theorem. Nobody likes the circle theorem. Right. Okay. Is it a circle theorem even? Right. P, Q, and R are points on a circle, center O. The angle POR is 120, so that's the angle at the center. PQ is 4. QR is 5. Work out the radius of the circle. Okay, right. I do not know. I do not know at all. Right, okay. There's my radius. That's what I'm trying to find. And it's the same as this. If I knew this side, I could find it. I know what I'm going to do. Right. The angle to the center is twice the angle to the circumference. So this angle must be 60. And then if I just look at this big rectangle from Q, which has angle 60, that's 4 and that's 5. I could find this side here. So that's PR I could find. Okay. That would allow me to find, so let's find this side X. So I'm going to use the cost rule to do this. So the cost rule maybe is remember is a squared equals b squared plus c squared minus 2bc cos a. This is a non-calculator exam. What a tough question, right? Okay. Right. Okay, so you've got your x squared then is going to be equal to 4 squared plus 5 squared minus 2 times 4 times 5 times cos of 60 from this triangle up here. Okay, and then cos of 60, we did this earlier on, I think. Cos of 60, what is cos of 60? Cos of 60 is a half. So let's just go through this all. It's going to be 4 squared is going to be 16 plus 25 minus 2 times 4 times 5 times half. That will just be 4 times 5, the 2 and the, that's a half, remember. So 2 and a half cancel out. 4 times 5 is 20. So what have you got? X squared equals 16 plus 25. What's 16 plus 25 going to be? It's going to be 30. It's going to be 41 minus 20. X squared equals 21. X equals a square root of 21. Okay. Oh, calculate the radius of the circle, right? So we've got that. So we've got our x is equal to the square root of 21. So now we're into this one. I do not know if this is the most efficient way of doing this. It will work, but it's going to be hard. Now we're into this next triangle. So in this next triangle, we know that's my radius, that's my angle 120, and that is the square root of 21. Could I do this a different way? I might do a different thing altogether here. I might just drop a perpendicular. I'm going to drop a perpendicular here, and then what that does is cuts that in half. It does two things. It cuts the angle and the triangle in half, but it creates a right angle triangle, which is the most important thing. So if I look here, this that wee length then from here to here is going to be root of 21 over 2. That's what it's going to be, root of 21 over 2. So let's just look at this, and that's my r. So I'm going to have my r. I'm going to have root of 21 over 2. I'm going to have 60 degrees. And yes, there we go. And then we can go with this. So it's a hypotenuse question. It's a SOHCAHTOA question, a trig question. This is my hypotenuse. This is my opposite. So we're going to use the old SOHCAHTOA. We've got sine. So we're just going to say, write that in, just keep us right here. Sine theta is equal to opposite over hypotenuse. Sine of 60 equals root of 21 over 2 all over r. That means r times sine 60. What is sine 60? Sine of 60 is root 3 over 2. So r times root 3 over 2 is equal to root of 21 over 2. There we go, we're getting somewhere. R then is equal to, multiply through by 2, you'll just get r times root 3 is equal to root 21. R then equals root of 21 divided by root 3. So r is equal to root of 7. Okay, and that's the end of the questions. Is any wonder that's a hard question? That's the last one. Very good. What a nice question. Okay, excellent. End of the questions. That is us done.